Okay, thank you for joining the next session. Just like with Jupyter Notebooks for Python, SQL Notebook in Business Application Studio allows you the execution of SQLScript and SQL commands in an interactive way. So Benedict will show us a SQL Notebook and run a cluster analysis using PAL, the Predictive Analysis Library in HANA Cloud. The results are then leveraged in Calculation View for further evaluation and visualization. Benedict is a freelance SAP consulting working on BV4HANA and HANA Cloud and machine learning in specific, and he's also the author of a book called Machine Learning mit SAP HANA Cloud. Thanks, take it away.
So there are still some exemplars available, so I don't have to versteiger this or somehow. Yes, so thank you very much for this nice introduction. So let me just add that besides of my consulting projects, I work also as a trainer for calculation views in cooperation with Jörg and Brandeis Consulting. So from that, you see somehow the motivation for my talk, machine learning with SQLScript and calculation views. And so in particular, maybe if you're interested in calculation views, want to learn about how to use these nice modeling tools, you're invited to book one of these courses on calculation views we offer. And if you want to stay in contact with me, you can stay in contact with me via LinkedIn. I have a short link. It's very easy to remember, Kurzlink/DRBB, or you can connect with me at Blue Sky at Dr. Baur Consulting. So let us go into the topic. So what is a cluster analysis? What could be the motivation for a cluster analysis? So let us think of some customer data segmentation. So assume you're given a data set of some customers of a bank or insurance company, so really large companies with a lot of customers, and assume you're working as a developer or consultant for that company, and you should analyze this data and get some insights from this data. And so such a data set can contain several attributes like the age of a customer, the location where he lives, maybe the salary, or information about the sales amount your company has with this customer. And you want to identify interesting groups along this data, right? To maybe understand the structure of your customers better, or develop some specific products for some groups of these customers. And you can explore such groups of customers using a cluster analysis. So you want to segment your whole data into groups of similar customers. And of course, the similarity is calculated using the attributes of your input data set. So the information you have about these customers. And yes, as you might guess from the description, of course, this is an explorative task. So it's not about just writing a specific program. It's some exploration. So you have to explore the data, maybe similar like we saw in the talk before about this graph data, where you explore data along these graphs. Now we explore data along these attributes. So in some sense, it's some kind of geometric data analysis. And how can we implement this? It was already mentioned in the introduction. We implement this cluster analysis using SQLScript. And there's a new feature in Business Application Studio. It's a so-called SQL Notebook. So I think it was released at the beginning of this year. So shortly before I had to write a session proposal. And I thought, okay, this could be interesting for data analysis. So I proposed, well, do some cluster analysis in SQL Notebook. So this SQL Notebook, it's a file, and this file can contain several block types. It can contain blocks of markdown, so just some descriptive text, or it contains SQL blocks. And these SQL blocks can be executed. You can put a single SQL statement inside, or you put some more complex SQL script statements inside. And of course, you have to connect the SQL Notebook with a HANA backend to be able to execute the statements. So independent of machine learning, assume you have a GitHub repository and you want to provide some setup instructions to those who clone this GitHub repository. You know, you always have to do some manual steps to get this running, and you could use a SQL Notebook for that. That you just write some lines of SQL statements to do some initial setup, or provide some interactive README. So not just a Markdown file with some text, but also with some SQL statements, which you could directly execute it after you have cloned this GitHub repository. So in our use case today, we will use it for some explorative data analysis. We will execute a cluster analysis in such a SQL notebook. So we use the PAL procedures for clustering. So the Predictive Analysis Library offers a whole spectrum of cluster algorithms. So there are really a lot of algorithms inside, and in the recent years, there have been further development to implement new cluster algorithms. So if you need more details, you can ask Christoph later on. And we embed this SQL script in our SQL notebook. And then what is important, we will store these results in a table for further analysis later. Yeah, so one step is executing the cluster analysis, and the second step is to analyze these results. So and how can we analyze these results? So that's the second step. We will model some calculation views to analyze the results. So in the first step, we will join the customer attributes, so the input data with this cluster assignment, and then we can analyze these cluster assignments in the context of these customer attributes. And then we can use this calculation view modeling features like window functions, aggregation, ranking. So when you know calculation views from Eclipse, you will know ranking and aggregation. And you might say, window functions and calculation views. So window functions and calculation views is a new feature in Business Application Studio. So it's not available in Eclipse or SAP Web IDE. It's available in Business Application Studio since 2022. So it was maybe at a time when there was somehow this Corona phases was somehow going down. These window functions were released. And maybe you remember in the context of Corona, you had to do some calculations like 7-day incidents where you need previous values from the day before and so on. And such measures can be modeled using window functions. It's quite interesting that maybe at the end of the Corona crisis, there was a new feature in calculation views which can be used to calculate these incidence measures. So I even in those days modeled such a calculation view to calculate such measures on some Corona incident data. Okay, but that's just a side remark. So we will use these tools for our to evaluate our cluster analysis. And so the nice thing about the calculation view is we can reuse it in different scenarios. So a calculation view is a quite flexible modeling tool. And when you do this data analysis, you can execute the calculation view on different aggregation levels with different filters applied. So you have a versatile, flexible tool. Okay, so that's somehow already the slides. I'm good in time. And so we have more time for the system demo. So maybe just a question, who of you is working with calculation views? Some people. And who of you is working with calculation views in Eclipse? And who of you is working with calculation views in Web IDE or Business Application Studio? Okay, so it seems quite balanced, right? It was not a, there's not a indicator that's only Eclipse or only web-based modeling, right? So somehow there are people who know both modeling tools, right? Okay. So now we are here in the Business Application Studio, and so I have really lots of time, so I can somehow slow down. So the base is a SAP HANA project. I provided also as a GitHub repository, so you can clone this repository afterwards and deploy it into your own HANA cloud. So I did not mention it explicitly. I'm working on HANA Cloud here. And there's a table, it's called churn. So this is our customer data. It's synthetic customer data. The name churn comes from the fact that actually this is a public data set used to train classification models for churn prevention. So churn means a customer leaves the company, quits his banking account or telecommunication contract. And so you use this data set for supervised learning, but you can use it also in the context of a cluster analysis of unsupervised learning. So this HANA project provides out of the box the data we have. And then we have this cluster analysis notebook. So here you see this SQL notebook. Who of you knows this already, SQL notebook? Okay, some people, but not much. And so maybe when you know Jupyter Notebook, you can execute some Python code, plot results. And this is somehow similar for SQL. So in the first step, we have to list our database connections. So these are the connections that are registered with your Cloud Foundry user. And I have to pick the right one. So I'm working in an HDI container because I have a HANA project. And so I connect to this HDI container. And then I can check that I have a connection. Yes, I have a connection. And the first step, what you do, you select some sample data, right? So we have some SQL statement here, and you see there on the right side, we have SAP HANA SQL. So this is the block type. You can have the block type markdown. So the captions are implemented as a block type markdown. And you have the block type SAP HANA SQL. And you can write a single statement, some sequence of statements, or you can encapsulate statements in an anonymous block. So we select some data from our customers. And I say random. So each time I execute this statement, I will get different data. So you get a first impression what kind of data is contained here. So we have customer ID, we have a credit score, age, balance, and so on. So we could do maybe some more things like doing aggregation or whatever, or doing some data profiling. So I will not do this here. I will go to the second part, the cluster analysis. So for implementing this cluster analysis, we need an anonymous block. So we started with a do begin. And then we can put all the statements we need for this cluster analysis. So in the first step, we build up some parameter table to configure this cluster algorithm. So here in particular, we say the group number. So we determine how many clusters should be constructed. And then we select our input data. So here I select the features I want to use for the clustering. And I filter on customers with balance greater 0. This is somehow in this data set, there are lots of customers with balance equal to 0. So I just exclude them for this analysis. So in practical life, you would do something other. You would choose a different strategy, like replacing this 0 values with the average value, something, or maybe exclude this column. But here, just a hand-waving strategy, just ignore them. And then we have here the call to this PAL procedure. So we call here the k-means algorithm. And yes, instead of calling the k-means algorithm, you could choose many other algorithms at this point. Yes, so I mean, the k-means algorithm is a well-known clustering algorithm, and it was also one of the very first algorithms available in SAP HANA. So I remember already 12 years ago, we implemented this k-means algorithm, used it in SAP HANA. And we store the results in a table. So here I have a table cluster result, and I store this execution together with a run ID, so to distinguish several runs. So I will execute several runs of this cluster analysis with different configurations so I can compare them. So let us execute it. Now we have an error, but sometimes I get this error, but it's not a problem. Just execute from the beginning again. and hope that it works. Just again say. So now everything works. So I even took some video sequence of all this for the case that it doesn't work. So that's why I'm totally relaxed if something does not work. But now you see we have executed this cluster analysis. So we are talking about 10,000 customers. After the filtering, it's about 7,000 customers. So we have a runtime of 0.3 seconds. Maybe if you have some more customers, it might run a little bit longer. And we can see the result. So in between of my SQL block, I had some statements like select star from some table variable. And the result of these select statements are then plotted as text here below. So it's the same principle as with Jupyter Notebook. Maybe you have a pandas data frame and you say data frame collect, and then it prints the result here. So this resulting table, we have the customer ID along with the cluster ID. So each customer is assigned to a specific cluster. And so we have stored this result for further analysis. And here we have the center points of our 5 clusters. And they are determined by this numeric and categorical columns, which are used for the clustering. And so we can have a look at these values. And maybe we see, okay, the average value of age and tenure, it's more or less the same along the clusters, but the values for balance and estimated salary, they differ along these clusters. So somehow this clustering was done along these 2 features. So before I go to the calculation view modeling, let's have a look at the second cluster execution. So what we do here is we introduce a normalization. So we rescale the numeric attributes. So that's important because the distance between these points are calculated using these attributes. So if you have an attribute which lives on a high scale, like balance with values maybe 150,000, it completely dominates the clustering. And a variable on a smaller scale, like age, ranging from 1 to 100 or 120, is then somehow dominated and does not have an effect in the clustering. And that's why I add this normalization here. And we do a very simple clustering now, just age and credit score. So if you remember this graphic I showed before, this use case of the bank, that you just want a segmentation by age and credit score, and based on this segmentation, maybe offer some specific products related to the age or the credit score of the people. And the rest is the same. So we just change the parameter table and this feature selection here. So let us execute it again. And again, we get this cluster assignment and we get the center points. Now the center points are calculated with the rescaled values. That's why we have now very small values for age and credit score. But you see from these values that now the cluster centers differ by age and credit score. So this was maybe lots of text and SQL statements. Now, if you really want to explore your data, I mean, you need some visualization of your data. You have to maybe draw a picture, and that's where these calculation views come now into the game. So I modeled some calculation views here. So we start with a very simple one. So we join our customer data and we join the cluster result. And our cluster result is stored in a table, cluster result. And I did not select the table directly. I selected the second calculation view. It's a dimension view. And this dimension view just makes a select on the cluster result, but filtered with an input parameter. So we have several executions, and the input parameter of this dimension views allows me to select one of these executions. And so I encapsulate it in a dimension view, so I can model this input parameter once and then propagate it to the other calculation views. So I don't have to implement this parameter and filtering all over again. Yes, so just a remark on calculation view modeling. Yes, and then we do some aggregation, and we define, so in a calculation view modeling, you have to define measures and attributes, and I have defined just a counter, so I can count the customers by the cluster. Okay, so let's have a look in a data preview, and then we will look in the more complex calculation views. So when you have a HANA project, you have the second tab in the Business Application Studio, which is somehow related to all things about HANA. So we have here somehow this HDI container. We can deploy our development, and we can open this HDI container to directly jump into the Database Explorer. And just another technical remark. So we have to connect our project to a target HDI container where we deploy our project into. And we need a second connection here to use this machine learning procedures. So these machine learning procedures live in this sysAFL schema. And if you want to consume them in an HDI container, you have to connect them, provide them via a technical external service. So this is just a database connection with a technical user. So it's simple to set this up. It's no magic behind. And in my GitHub repository, I've supplied a detailed description how to do this setup step. So let us look now in the in the Database Explorer. So we get here our compiled calculation views. So we have here this CVC cluster result enriched. And so now we have this input parameter. We can select a run ID. So let us start with run ID 1. And we can plot a bubble chart. So you remember from the center points, we had balance and estimated salary where the clusters differ. And we take the cluster ID and the drill down. And we get a nice scatter plot indicating these center points of the clusters. And I can add a third measure, the count of the customers. And then I have a bubble chart which indicates the size of these clusters. And you see they differ by balance and salary. Now let us choose the second execution where we just clustered by age and credit score. Then, well, let us again view balance and estimated salary. Now the result is not so clear anymore. Yes, they are somehow, if you look for these two measures, they are more or less at the same positions, the clusters. But now let us visualize against the attributes that we used in the clustering. This was age and credit score. Now you see the center points differ by these two attributes, age and credit score. So we have a clustering by age and credit score. Now, if you want to have a deeper understanding of these clusters, you can go into two directions. You can plot a scatter plot on a very detailed level, or you can somehow analyze the distribution along these numeric columns. And let us first look at the scatter plot. Now, if I take the customer ID inside, then I see somehow the full clusters. Now, for every customer, I have a data point here. So I see the shape of the clusters, but this graphic has some disadvantage. You have lots of data points now. So we have 10,000 customers, so 10,000 data points. Assume you have 100,000 customers, 100,000 data points. And using this function, using this window function, you can do a trick. You can do a random sampling along these clusters that you say, give me just 20% of the customers in each cluster. So you can reduce the amount of data. And I will first show the calculation view in the data preview, and then we look at the modeling in the back end. So now it asks me for an additional input parameter, the sample part. So this says, what is the percentage of customers you want to display in each cluster? And I reduce it to 20%. And we choose again run ID 2. And for the calculation view experts, I have also an input variable here, which filters on a column just by a constant value 1. So this filter provokes that we really select just these customers which are in the sample. You will see it in a minute. Now we can plot again the scatter plot by age and credit score. And so it looks like more or less the same, right? You don't see really a difference. So where you see a difference somehow in the outer parts of the clusters. So they are more sparse now. So here we have our dense areas with lots of customers. And then at the boundaries of the clusters, we have less customers. Yeah? But you still get the shape of the clusters. And you get also an impression inside these clusters, where are the areas with lots of customers and where are the areas with not so much customers. And well, it's really, we have really done the sampling. So you see the result are just 2,000 points. The original data set has 10,000 points. So really this random selection has taken place. And just again, it's a massive reduction of the data transfer we have. So let us have a look on how we modeled this using this window functions. So here I have this calculation view random sampling. So the first part looks the same as before. We have the connection between customer and the cluster result. And then I have this additional node type window function. And in this window function, you have this tab definition. And we have to define a partition. So we say partition cluster ID because we somehow execute this window function on each cluster ID. And we have created a column called random sample. And here we have used the SQL window function random partition. So this random partition splits a partition into 3 subsets. So actually it's used in supervised learning, like training classification models. So I use it here now as a trick to do this reduction. So I say training set size is given by an input parameter. This was the prompt we saw. And this window function assigns each row to one of these 3 subsets. And this resulting column rand sample indicates to which column, to which subset should this row belong. Yes. So if the row belongs to training set, the column rand sample has just the value 1. So, and in the calculation view, I filter on the column rand sample equal to 1. And this induces this random sampling, this filtering just on the customers in this first set. So in this way, I can implement a random sampling using calculation views and this window functions. Just one word of caution, when you do now some aggregation or statistics, you should do it on the calculation view with the full result set. So on the calculation view without the filtering, because this random sampling, this filtering, of course, maybe changes your statistics in the data. So this calc view is really just for the visualization. And I have another calculation view. When we want to count the customers per, for example, age column, we can do a discretization of this age column. So the age column is a numerical column, and we can transform it into a categorical column by building intervals for this age range and assigning each customer to one of these ranges. And this again can be done using window functions and calculation views. Let me first show the result and then the modeling. So I've implemented a dimension view with the logic. So from that, you will see what happens here. So on the left side, I have the different values for age. And I have a new calculated column age bin, which represents an interval. So each value for age is assigned to a unique interval. And these intervals are constructed out of the value ranges. And we can use this discrete column age bin again to aggregate the customers, because we can aggregate on a categorical column, on an attribute. So this was this calculation view. So let us choose one ID number 2. So now we are in the aggregated setting. So we choose the spinning column, which indicates the interval. And we choose the cluster ID. And we choose our counter. And so we can count now by age or age group and cluster ID. So we can plot an histogram, or maybe first we drop the cluster ID. So we can plot an histogram on the whole data set. So we understand the age structure of the customer. So before analyzing the age structure in the clusters, you should have a look at the age structure on the whole set. And then we can drill down by cluster ID. And then we get the age distribution along each cluster. So maybe this cluster 0, it was the blue cluster on the right side with higher ages. It starts with somehow 46 and goes up to 92. And these 1 and 3, they are somehow in between from 18 to 52. And cluster 2 has a broader range. Yes, so from this graphic, you get an impression of the age distribution. And there's another nice visualization. It's a heat map. So there you can really see where's the concentration of the age groups. So again, cluster 0 with this higher ages. So the gray cells means no value, so really no customer in this age group and that cluster. And so cluster 1 and 3, you again see this concentration there in these age groups. So the sorting is a little bit mixed. That comes from the fact that cluster 0 does not have customers in all age groups. And again, keep in mind, this is a highly aggregated review. So we just have a data point for each cell. So 5 times 10, so 50 rows. So the data transfer to the client is very reduced, and all the calculation is done at the HANA side. The nice thing here about this. So just imagine the use case, maybe you have 100 or 200,000 customers, then you can still plot such a nice image, because on the client side you have very less data, and all the data operation takes place in HANA. So let me finally show how we can construct this discrete column using window functions. And as I mentioned, I have encapsulated this in a dimension view. So again, I encapsulate it in a separate calculation view so I can reuse this logic. Now we have several steps of preparation, but I think it's more or less self-explaining by the labels of the node. So the first node is an aggregate node. What I do here is I want to have the distinct values of age. So I do an aggregation on the age column, and this results in having just the distinct values of age from the data set. So each value of age just once. And then we have the window function, which creates the binning variable. So here we look into more details. So again, we have the definition of the window function. And we have here a function called ntile, which means split the data into a certain number of buckets. And we have no partition here, but we have the column age. So first we do the select distinct on the age, and then we say, okay, order by age, and then form these 10 buckets. And this yields the intervals. And each value of age is assigned to a specific interval, to a specific bin. And finally, we do a window aggregate function. So in order to get this interval boundaries, I apply a minimum aggregation and maximum aggregation along each of these bins to get these boundaries. And from this, I can draw this nice label you saw in the data preview, like 18 to 24. Okay, thank you. And 5 minutes to talk, right? Yeah. Oh, perfect. So with this, I wanted to show how you can use this calculation view modeling to evaluate your cluster analysis and this nice new features we have in the cloud-based calculation view modeling. So in particular, this window function here, which really increases the set of functionality. I have written also a blog on cluster analysis and calculation views. There are two other very interesting features. So one feature is using table functions with tabular input parameter. So in the classical Eclipse-based modeling, you cannot use table function with tabular input parameter. This is available also from Web IDE, which also allows you to model some reusable logic. And there's another new feature in calculation views. It's snapshot functionality. So you can create snapshots of calculation views. And well, I have one more slide. I mentioned in the abstract, I maybe motivate on the role of this HDI container-based development in the context of machine learning. So when you do machine learning, this classical maybe separation of an SAP landscape in development, QA, and production breaks down because you have to develop your machine learning algorithms again, productive data. So maybe a subset of your productive data, maybe anonymization, no problem. But somehow you cannot develop a machine learning model on dev system and transport it to production and see what happens. And using HANA and these HANA spaces, you can create such scenarios like here. So assume you have a HANA cloud with your productive data, so with our customer data, and you can define separate spaces. So you can define a space for machine learning, and you provide this machine learning data via an external service into the space, and you assign your data scientists some developer roles. So they can develop calculation views, some stored procedures for the cluster analysis, and they can work in this data experiment space completely independent from some productive applications. And well, you use the calculation views for this evaluation of the results. And if you have consolidated this cluster logic that you want to reuse it in a daily business, you can somehow deploy this logic to an HDI container in a production space. And in this production space, business users have access to this data using some front-end tools like SAP Analytics Cloud, and they can consume this calculation views in the front-end tool and see this cluster results. Yeah, so you can use the calculation view in both scenarios, in the experimental phase for evaluating, for experimenting, and then in the production phase just to expose these results to the business users. And it's the same modeling tool. That's the nice thing here about. Okay, and now I'm finished with my talk, so it's time for QA. And again, if you want to stay in contact with me via LinkedIn, Blue Sky, I have this GitHub repository. And if you're interested in calculation views, there will be a course on calculation views at the end of September, which I will hold.
Thank you so much, Benedict. Yeah, great to see how SQL notebooks and calculation views can be used to work interactively with the data that is in HANA, a little bit like we know, or I know from Python Jupyter Notebooks. Great to see. There is one thing that I learned recently, and that is that some PAL algorithms, especially for classification and categorization, do support the vector data type. That means you can make natural language text, for example, product descriptions, run through a text embedding function and get a representing vector and use that vector as a first-class feature in PAL algorithms. Open up natural language text as a feature for PAL algorithms. But that's just a side note. Open to questions now. Who's first? Okay.
Everything was clear.
Sorry, maybe it's unrelated and I might know the answer already, but I was completely oblivious to the fact that there was something like a SQL notebook in Bash. Would it also be possible to not connect to an HANA database, but to the CAP layer first, and then using SQL statements?
To what layer?
To the, for instance, if you have a CAP application which connects to HANA.
Okay.
So CAP as the middleware. Take your queries for CAP. I might ask someone from the CAP team instead, but
yes,
I think it's
so what I know from CAP, it's compiled to some kind of application, maybe a Node.js or Python application and some database objects. And then in the database level, you again have this HDI containers. So, yeah, the SQL notebook the SQL notebook always consumes runtime objects. So you're always in the HDI container. So you connect to the object. Indeed, yeah. You connect to the objects that have been created by the CAP application.
Okay, next one over there.
Yeah, hi. Thanks for the cool presentation. Just like a question about how this is like related also to Databricks, because Databricks offers like a similar functionality, but yeah, it's not on the database at the end. But what is your recommendation at the end? Because there we can also work with SQL and Python together. Instead of here in this level, just staying either with Python or with SQL, as I understood. So maybe just from your point of view, what would be recommendable to use?
So I understand one question is about Databricks versus SQL Notebook, and the other question about Python versus SQL, right?
No, it's like also to combine each other and like to make this kind of machine learning experiments. So it's always a good option, like to combine Python and SQL maybe.
Yes, so first of all, I have to admit about Databricks, I know not so much. I think this SAP Databricks, it came up some months ago. So I think there is some kind of notebooks in Databricks, so you can use it to somehow maintain different states, maybe different strategies for training your model or whatever. And so as far as I have understood, I mean, you can execute the HANA algorithms for machine learning, or you can transfer the data somewhere in the Databricks environment and do some Python algorithms on it. And well, of course, somehow in the free world in Python, there are many more algorithms available which are not available in HANA yet. But I think if the algorithm is available in HANA, it would be best to use the HANA implementation. Maybe you can also ask Christoph about this. And about the question Python or SQL script. So if you use the HANA machine learning algorithms, you have the choice whether you use SQL script or Python. And I would say it depends on you as a developer, with which language are you more familiar, and what do you have in mind where to integrate it. I mean, SQL script fits perfectly into SAP applications. You could execute such a cluster logic on an ABAP-based system, S4, BW, or maybe in DataSphere by connecting to HDI container. So I use both Python and SQL script. And you see in my book, both are written, maybe about 50% each. But maybe one remark, if there are new features in PAL, I think they are first available in SQL script, and it might take some time until they're available in Python API.
Okay, that's right. One more question.
Maybe I saw it in your samples, but you didn't necessarily show it. Why didn't you use the PAL procedure as part of a table function wrapped within the calculation view? Is there a reason why you didn't show that? You stored the cluster results in a table.
Mm-hmm. And what was your suggestion to?
Yeah, to dynamically call the clustering function in a table function mapped into the calculation view.
So I showed this last year at the hanatech conference. So what Christoph mentioned, you could embed this cluster logic in a table function and execute it in a calculation view. This is also a scenario, a valid scenario. So at this point, you would always execute the cluster logic when you trigger the calculation view. Yes. So you can do this, but it means every time you execute the calculation view, you execute the cluster logic again. But the cluster logic is, of course, somehow time intensive. Yes, and you would execute it over and over again. And also the results are sometimes not deterministic at the cluster logic. Yes, so I did this strategy to do the decoupling in particular because in a notebook, somehow you can freely experiment. Just change the code, try a little bit. And then in the second phase, you have this consolidation phase.
Okay, that brings us to the end of the session. Thanks again, Benedict. And